Today, we are covering the paired samples t-test, the essential tool for validating the effectiveness of your project. We're going to use employee productivity data before and after a training program to see if that investment actually paid off. If statistics feels hard, don't worry. This test is all about evidence-based ROI. The paired t-test is used when you have quantitative data, numbers that measure performance such as employee productivity scores, average transaction value, or processing time. The critical difference is that we are looking for a change within the same group of people. Simply, we compare a score before the training to a score after the training. The paired t-test is your go-to for impact assessment. The core business question is like, did the training system process change cause a statistically significant difference in performance? You've already invested time and budget, right? This test provides the objective evidence to prove whether the change actually occurred, or if the small improvement you saw was just random fluctuation. We framed the analysis to prove the intervention worked. No hypothesis, no change, no impact. The average productivity score is the same before and after the training. In other words, the training was ineffective. Alternative hypothesis, on the other hand, a change exists. The scores are different after the training. Our goal is to find strong evidence to reject the null hypothesis and justify the money spent. The first step is simplifying the data. We don't analyze the before column and the after column separately. Instead, we create a third column, the difference score. By calculating the difference for each employee, we reduce the problem to one simple question: is the average of this new different column significantly different from 0? Now, we analyze this new difference column in terms of average and a standard deviation. On average, productivity went up by 3 points. But how consistent was that 3-point gain? Did everyone improve by 3? Or did some jump 10 while others dropped at 4? The standard deviation tells you the variability or noise in your training impact. Just like in the last video, we convert our data into a t-value, also called the signal-to-noise ratio. Think of it this way. The signal is the effect you are interested in. For example, the average improvement after training, like a 3-score increase. The noise is all the natural ups and downs in the data, the variation between individuals. So large t-value, the average gain is big compared to the noise, meaning the improvement is consistent across participants. This gives strong evidence that the training really had an impact. On the other hand, small t-value, the average gain is tiny or inconsistent. Some people improve a lot, others don't improve at all. This gives weak evidence, and the effect might just be due to chance. So the t-value tells us how clear the effect is compared to the random variation in our data. The bigger the t-value, the more confident we can be that what we see is real and not just luck. Well, the software that gives us the p-value. When p-value is less than 0.05, it becomes evidence to reject the null hypothesis. The t-value is strong enough. So we can draw a conclusion that the productivity increase is statistically significant. This is where the parity test becomes essential for a decision maker. About training validation, the 20-hour course justify the cost. This test provides the proof of concept for future budget requests. How about system implementation? We can compare the average time to task before and after switching to a new CRM system. When it comes to process improvement, we can evaluate the impact of new manufacturing procedure on defect rates using a pilot program. This test turns your subjective belief into an objective evidence-based fact. Remember the simple flow of the parity test. 1. Measure the same subject at 2 points in time. 2. Create and analyze the difference column. 3. Determine the strength of the average change relative to the noise. 4. Your final verdict for ROI validation. Stop second-guessing your investments. The power of this test is not in the formula, but in your ability to confidently interpret the output and persuade stakeholders with objective evidence.